Hello everyone, I'm Mahin Fatima. I'm studying in CSM in Srinivas Ramanujan Institute of Technology. My artificial intelligence assignment topic is review of probability. Let's go into the topic. First, introduction to probability. Probability is a branch of mathematics that deals with uncertainty and the likelihood of events occurring. It provides a systematic approach to quantify and analyze uncertain situations. Understanding probability is essential in various fields including statistics, finance, and science. Next, definition of probability. A well-known and well-understood framework for dealing with uncertainty is called probability. Probability is defined as a measure of the likelihood that an event will occur. It is expressed as number between 0 and 1, where 0 indicates impossible and 1 indicates certainty. That is, 0 is impossible event and 1 is called sure event or certain event. Mathematically, the probability of an event A is denoted as P of A and can be calculated as the ratio of favorable outcomes to total possible outcomes. Complementary event represents all the outcomes not included in event A and their probabilities. Sum to 1, P of A plus P of A complement is always equals to 1. Next, event and its probability. Definition. A subset E of outcomes E is called an event E. Probability of event, we have the formula P of E is equals to total number of outcomes in event E to the total number of outcomes in sample space S, that is equals to N of E by N of S. This can be understood by taking this example here as shown in the slide. Here we have different colored number balls. Here there are two colors, red and blue, and the total number of balls, different colored balls, are 10. So it is called as sample space, and we have two possible outcomes here, that is balls of same color and the balls of different color. 4 balls of same color and different color. Now the probability for getting the balls of same color is equals to 4 by 10, that equals to 2 by 5. Prepositions. Random variable refers to a part of the world whose status is initially unknown. Example, cavity referred to my lower left wisdom tooth has a cavity. Capital letters are used as names of random variables. Random variables can be divided into special 3 kinds depending on the domain. First, Boolean random variables, that is true, false, and second, Boolean random variables countable in 0, 1, 2. Next, we have two types of events, independent events and dependent events. The outcome of one event does not affect the outcome of the other. It is called independent event. If A and B are independent events, then probability of both the occurring is P of A and B, that equals to P of A into P of B. And next, the outcome of one event affects the outcome of the other. This is called dependent event. If A and B are dependent events, then the probability of both the occurring is P of A and B, that equals to P of A into P of B by A. That is, if the event A occurs, then only the B occurs, so it is called dependent event. Next, sample space. A sample space is a set of all possible outcomes in an experiment. Example, it can be understood by tossing a coin. Represent the sample space for this experiment by making a list, table and tree diagram. When 2 coins are tossed, the sample space we have 4 like we can see in the figure. Table, head, tail. We get the sample space, the resultant sample space as head, tail, comma, tail, head, comma, tail, tail. Next, probability rules. We have two probability rules, addition rule and multiplication rule. First, addition rule. It states that probability of union of two mutually exclusive events is the sum of their probabilities. That is, P of A or B equals to P of A plus P of B. Next rule is multiplication rule. It applies to independent events where the probability of both the occurring is the product of their probabilities. P of A and B equals to P of A into P of B. Addition rule of probability. You can see in this diagram. Next, prior probability. It is the probability of event occurring based on existing knowledge before new evidence is considered. Posterior probability. It is the updated probability of an event after taking into account new evidence or information. Next, conditional probability. Conditional probability is the probability that one event A will occur when another event B occurs. A conditional probability can be denoted as P of A by B. P of A by B equals to P of A intersection B by P of B. Here the Venn diagram shows the conditional probability P of A by B equals to P of A intersection B by P of B. Next, applications of probability. We have many applications of probability like statistical inference, machine learning, Bayesian analysis, risk assessment, quality control, anomaly detection. Like this, we have many applications of this probability in artificial intelligence, machine learning, and all. Thank you for giving me this wonderful opportunity. I hope you found this video insightful.